So today, let's do something a little different. We're not going to start with some dry math problem. Nope. We're going to start with a story. It's about a young girl named Carlota who, a year after her grandmother passed away, finds a secret she left behind. A secret that turns a dusty old box into this incredible adventure in mathematics. So the big question is, what was inside that box?
So Carlota cracks open this little safe. And what does she find? You guessed it, another box. And inside that one? Well, she's probably thinking this is just like one of those Russian matryoshka dolls, you know, where the boxes just keep getting smaller and smaller. The mystery is already building.
All right, so after all those boxes, what was waiting for her in the very last one? Let's get into the secret that her grandmother wanted her to find.
She carefully pulls out this thing. It's this really cool kind of steampunk-looking machine, you know? It's got tubes sticking out, gears on the side, a little screen, a keyboard, just totally wild and unlike anything she's ever seen before.
So her first thought is probably what your first thought would be, right? Okay, maybe it's just a really fancy old-school calculator. So she tests it out. She types in something simple, 2 plus 3, and yep, the screen lights up with a 5. It works, but it seems way too complicated for just that.
And that's where things get really interesting. Sure, it can do basic math, but what about all these other keys? What are these letters, F, X, and Y for? This is where the real investigation kicks off.
Okay, so this is where we really get to the heart of the mystery, and it all boils down to 3 simple ideas: inputs, rules, and outputs. Then, Carlota finds this other little thing that came with the machine, a small ball. But this isn't just any ball, it's kind of magic. When she thinks of a number, poof, it appears right on the ball. So she thinks of the number 3, and she drops the glowing ball into the tube on the left. That's our input. The second she drops it in, the machine just springs to life. It's whirring, there are lights, all these cool noises, and a second later, a new ball pops out the other side. And this one has the number 7 on it. That's our output. So an input of 3 gives us an output of 7. What's going on here?
Now Carlota's really curious, so she's got to see if there's a pattern. She tries again, this time with the number 5. The machine does its thing, and out comes a ball with the number 11. So, an input of 3 gets you a 7. An input of 5 gets you an 11. Are you starting to see a pattern here? What's the machine doing?
Carlota thinks she's got it. She's got a theory. So what do you think? If she puts in a 4, what number's going to come out on the other side?
And she was totally right. She puts in the 4 and bam, out comes a 9, just like she thought. You can just imagine her jumping up and down. She's cracked the code. The machine is following a consistent rule every single time.
And this is that amazing aha moment. This is where we go from a fun little puzzle to a huge mathematical idea. It's time to crack the function code. So, Carlota finally gets it. The machine is following a simple rule. It takes whatever number she puts in, let's call it X, it doubles it, and then it just adds 1. Think about it. Twice 4 is 8, plus 1 is 9. Twice 5 is 10, plus 1 is 11. It works every time.
And what she just discovered, well, that's the very definition of a mathematical function. It's just a fancy name for a rule that takes one thing, an input we call X, does something specific to it, and spits out one single predictable output, which we call Y. This machine is the perfect way to picture it.
And that's when it all clicks for Carlota. This machine wasn't just some old calculator. Its whole reason for being, its entire purpose, was to be a function. Her grandmother's secret treasure was a function machine.
But wait, here's the best part of this whole thing. This isn't just some made-up story. It actually has a real-world origin, and it was born out of a real need in a real classroom.
The guy who created it, a teacher named Sergio Machado, basically said it himself. He came up with this whole thing because he needed a better way to explain functions to his 7th graders. They were struggling, you know? So he decided to get creative.
And the way it happened is just awesome. One day in class, Sergio starts drawing this machine on the board. You know, a slot for a number to go in and a slot for the result to come out. A student asks what it's called. Right at that moment, another student, her name was Carlota, walks in late. And just like that, Sergio goes, "It's Carlota's machine." And that simple drawing turned into this amazing story.
All right, so let's wrap this up by looking at how this one simple story evolved from a classroom drawing into this incredibly powerful new way to learn.
I mean, the idea literally jumped right off the chalkboard. On the left, you can see one of the original drawings. But look at the right. Those are real, physical models that Sergio and his students actually built out of stuff like old cardboard and cereal boxes. How cool is that?
And what started as a classroom drawing has had this incredible ripple effect. It's been used in workshops to train other teachers all over the country. It even inspired other math stories, like one called CSI, Mathematics. It was turned into a stage play, and probably the best part, it's inspired tons of students to just go out and build their own function machines.
Just take a look at these. This amazing collection of handmade tools just goes to show how creative and accessible learning can be. It's proof that you don't always need high-tech gadgets to get complex ideas across. Sometimes you just need a really good story and a bit of imagination.
It really makes you wonder, doesn't it? What if the key to understanding some of these really big, complex ideas isn't hidden away in some dusty old textbook, but is just waiting for us to find it in something as simple as a biscuit box?